So what's center? So you know what center of mass is, and you know center of weight. Okay, you need both are same on planet Earth relatively. If you take it to the deep space, there won't be any center of weight. There will be only center of mass. Okay, now centroid. What's centroid? The centroid C is the point which defines the geometrical center of the object. Is the geometrical center. That's the geometrical shape. That's the center of it. And it will also be the center of mass. There's a geometrical shape, and that's the center of it. Now, the centroid coincides with the center of mass or the center of gravity only if the material of the body is homogeneous. That's basically the density or specified constant throughout the body. I will show you. Just wait. It says sometimes the centroid is located outside the body. That's strange. Look, this is a heavy metal. It's a heavy metal. Okay, it's of steel. Its center would be outside the body. I make an N-shaped object, very heavy. Its center of mass will be somewhere here. Centers. Okay. Now, let me explain the difference of the two. If an object has an axis of symmetry, you know what axis of symmetry? Split it, it becomes half, mere half. Then the centroid of the object lies on the axis. So if I've gotten a square, that is the axis of symmetry, that is the axis of symmetry, that is where the center lies. If I have a circle, and that's the center of symmetry, that is axis of symmetry, and that is where the center is. If I have a triangle, that is the symmetry point. So my center will lie on this line. That way it says here. Now I want you to understand this one, center of centroid. Now this is an object here. If we want to take the center of the geometry area, it comes out to be this. Okay. Now, if I and that is the center of geometry. Let us say that is also the center of mass. But if I add a weight to one end, then the centroid is the center of the area where the center, your center of mass or weight has shifted because you got additional weight here. So the density has changed. This is a different density. Is that clear to everyone?
Yes, sir.
This is, I guess you've done it in college something. This is very simple. I'm just covering it so that in the coming semester you will go through in detail. Okay. The center of the mass and the center of gravity of an object are in the same position if the gravitational field in which the object exists is uniform. Very interesting. Look at this. What it says here. That's Earth, that's the object here. So the center of mass and my center of gravity is the same. I've got the moon here, which will disturb my gravitational field. So my center of mass is the same. That doesn't change. My center of gravity has changed because it depends on the gravitational force. So remember, your center of mass never changes. Your center of gravity can change if the pull of the force, either Earth or any other object, comes near to the body that you're investigating, then your center of gravity will change. Around planet Earth, mostly the center of mass and gravity is the same. Okay, so let's go through a very simple way of finding the center of mass and gravity. So let's look at it. The I-beam is commonly used in building structures. That's an I-beam. Why it's called I-beam? Because it is the shape of an I, capital I. So it's an I-beam. When doing a stress analysis on an I-beam, the location of the centroid is very important. How are you going to find it? So how can we easily determine the location of the centroid for a given beam shape? Similarly, another look at that. Car, truck, bikes are assembled using a number of individual components. When designing for stability on the road, it is important to know the location of the bike's center of gravity. You got different components, and then you need to know the center of gravity of it. How are you going to find the center of gravity through individual components? If we know the weight and center of gravity of individual components, how can we determine the location of center of gravity, CG, of an assembled unit? So if I know the center of gravity of the wheel, center of gravity of the wheel, that's here. Center of gravity of this wheel is here. Center of the engine is here. Center of the seat is here. Center of the body is here. Center of the handle is here. How I'm going to find out the actual G? Where is the center of gravity, or center of mass? How am I going to do that? It's relatively very simple. Let's have a look. Remember one thing. One can determine a centroid location by utilizing the cross-section view of a three-dimensional object. That's my three-dimensional object. Where is center of gravity would be? If I look from here, that's this object here, then it's very clear it's an I-beam. So its center would be here. So if I take a cross section of it, it's very easy to find the center of gravity or the centroid of object. Few things. Centroid location is determined by an object's line of symmetry. I just mentioned you that. The centroid is located on the line of symmetry. Oh, come on. That's where if I split it, I'll have mirror image. So that's my center of gravity would lie on this line. I've got square split it like this. I've got mirror image. I split it like this. I get a mirror image. If I split like this, I get a mirror image. Or if I split like this, I'll get a mirror. So my centroid would lie on that line. If I split it like this, it is not a mirror, image. Okay, it's not a symmetric line. Sphere, a circle, I can have it has got a defined number of line of symmetry, and the centroid is basically lies in this sense. So, how we are going to find the center? Okay. The centroid of a square or rectangle is located at a distance half its height and half its base. Oh, this is so important. I guess you didn't know this. Am I right?
Yes, sir.
You didn't know this.
Yes. Sir, we didn't exactly know the formula, but we can like judge it by knowing like drawing the line of symmetry, and we know that we have to cut the square in half. So
yes, that's what I call common sense. You need more common sense in engineering than any other field. Okay, so the center or the centroid or the center of this square is half the height and half the width. That's there. Okay, and this is the basically symbol for the center of gravity along x-axis, along y-axis. So remember, I want you to remember what this is. That is basically the distance from reference x, and this is the distance from reference y. Centroid of a right angle triangle is located At the distance, 1/3 is height and 1/3 is base. So my axis is here. Watch, my axis is here. So it will be x dash and y dash. Watch. Come on. That's where your centroid is. Remember, I will not tell you, you have to remember this. It is 1/3 the height and base of a right angle triangle. So common sense tells us, if I have a triangle something like this, is this a right angle triangle? Okay, hold on. It doesn't look like. Let me make it. Oh, come on. Is that a right angle triangle? Why I am struggling in making a right angle triangle and not a right angle triangle? Yes, that's better.
Interesting.
Okay, now let's look. I've got this triangle. The only thing I know is this. How I'm going to find the centroid. So what I'll do is split it. That's my right angle, so I can find the center of gravity here, and I can find the center of gravity here, and then later I can do the sum, which I'll explain. Is that clear?
Yep.
Okay, the centroid for half a circle or semicircle is located at a distance of this away from the axis of its line of symmetry. So again, these are such formulas available. You can then solve those. So in simple words, remember center of, this is basically what I was explaining. This is something like, I'll bring that same triangle out. This is my y-axis. This is my x-axis. I can split it into two. I can find the centroid here and I can find the centroid here. So it says that looking at x, you want the center, you want the x, that's the center of the whole triangle. So I will do summation of this into this distance plus this into this distance divided by the total area. Sorry, the area of triangle, area of triangle 1 and triangle 2. So triangle 1 area multiplied by its distance x1 and triangle T2 multiplied by T1 multiplied by x1 plus T2 multiplied by x2 divided by the T1 plus T2 area. That's what exactly it says here. You will be able to find your x. That's common sense. Is that clear?
सर ये x इनके दरमियान मिडवे होगा हमेशा?
X, you talk about x dash?
सर जो हम ये सर x dash जो हम निकाल रहे हैं सेंट्रॉइड की लोकेशन.
Yeah, it will be somewhere in the center, but you better not to assume. Just calculate it.
ठीक है सर, अगर कहीं मेंशन हो कि सेंट्रॉइड इनके सेंटर में, तो मिड पॉइंट फार्मूला यूज कर सकते हैं अगर हमारे पास इस तरह उसमें दिया हुआ है कार्टेशियन.
Look, there are three different ways of finding a center. One is basically you split it into known composite component and known component shape, like square, circle, triangle. If you can divide it into that, then you can find the center of each shape. The other one is through the integration, which we're going to learn in the coming, I guess, not next year, I guess second year, fourth semester, I guess, where you do integration. Where in the integration, I will just explain you. In integration, basically, you split it into very small slices, and then you calculate the centroid of each slice, and then you sum them up. And the third one is basically SolidWorks software. You put it in the software, it gives you all the information you want. Nowadays, software is the best that you can use, because engineering is so complicated now. You need to use tools. If you don't use tools, you will not be able to do complex problems. Anyway, I'll